Sometimes we want to perform some operations on an array without changing the contents of the original array. In this case, it is useful to know how to make a copy of the array. To illustrate, let's make a secret copy of my shopping list so I can cheat on my diet. Consider this example. We have our shopping list, and to make a copy of shopping list, let shopping list copy equals shopping list. And now let's add some chocolate to my shopping list like this. Shopping list copy push an object with a name chocolate and quantity 1. Now let's check the contents of both arrays. We added chocolate only to the array copy, but it ended up in both arrays. How can we explain that? Arrays, like objects, are reference types, which means the variable shopping list is a reference to a place in memory that stores the values. When we executed this line, let shopping list copy equals shopping list, we ended up copying this reference, so now both shopping list and shopping list copy point to the same place in memory. That is why, by modifying the array copy, we also modified the original array. We can even check if both references are equal like this, console log shopping list equals shopping list copy, and they are equal. To make an actual copy of the array, we can use an operator that we already got familiar with in the previous lesson. So let's replace this line with a spread operator like this. Shopping list copy equals spread operator shopping list. Now, when we run the program again, a new item was added only to the shopping list copy, and both references are not equal anymore. Another way to copy an array is to use familiar methods like slice or concat, which also return shallow copies of an array. Let shopping list copy equals shopping list slice, or shopping list copy equals shopping list concat. And you can use either of these methods to copy an array. Now, I decided that I also want to buy sneakers instead of apples, so let's modify the first element of the shopping list copy. Shopping list copy at index 0, name equals sneakers. But something weird happened again. Apples in the original list were also affected, and now everybody knows I'm cheating on my healthy diet. This happens because by using the spread operator, concat or slice method, we make a shallow copy. That means we have made a copy of an array, but if we have other reference types, like object as items in the array, the copied array still references the same objects as the original array. This would not have happened if the array was made of primitive type values like numbers, of course. So, if the intention is to copy an array of objects and not have any modifications affect the original array, we need to make a deep copy. The simplest way to achieve that is to parse an array to JSON format and then turn it back to an array like this. Let shopping list copy equals JSON.parse json.stringify shopping list. Now, when we modify elements of the copied array, we only affect the elements in the copied array because all the objects inside the array were also copied. It's important to remember the difference between shallow and deep copies, so let's practice what we just learned. Pause the video and try to find a solution yourself. When you are ready, press play to see an example solution. And here is an example solution. Let's declare the array with numbers. Let numbers equals 1 2, 3, 4. And now let's make a copy of numbers and modify the first element to be 10 like this. Let numbers copy equals spread operator numbers, and then numbers copy at index 0 equals 10. Now let's declare the array of people. And to make a shallow copy and add a new person, let's use let people copy equals spread operator people copy push an object of name Jane and age 30, and the original array is unchanged, and copy includes Jane. Finally, let's make a deep copy and change mark to JSON. So let people deep copy equals JSON.parse, json.stringify people, and people deep copy at index 0 name equals JSON. And the original array is unchanged, while copy has JSON instead of mark.